Well, good evening, everybody. My name, as Chad said, is Robert Welbourn. Before I start, I'd also like to thank Google for their hospitality tonight, and I'd very much like to thank them for all they've done in getting WebRTC to fruition. Whenever people used to hold award ceremonies for the best WebRTC-related product, Chrome never ever won, but yet it was the foundation of everything, pretty much. So big thanks to Google for that. I'm the local sales engineer for Twilio. I'm based out here in the Boston area. I did serve some time doing technical support, and when I say serving time, you know, the jail analogy is kind of appropriate. During that year and a half I did support, I got to experience firsthand some of the problems people have with real-time communications in browsers. So hopefully you'll be able to benefit from some of that tonight. Cast your minds back to 2013, a long, long time ago. It was when the hype cycle for WebRTC was really just getting going. And we used to see headlines like this in the blogs and the tech press. WebRTC is the Skype killer. All hail the Skype killer. Funnily enough, not quite. So more informed observers said, well, no, this is a very good thing for building into applications and services for creating real-time communications. You've got an app and you want to add voice or video. This is the perfect thing to do it with. As it turns out, my employer, Twilio, by the way, who's heard of Twilio before tonight? Well, that's pretty good. I've been in the communications business since 2008. It got started when Jeff Lawson, who was then CTO of StubHub, wanted to send text messages to his customers about their ticket purchases. And there was no easy way of doing it. You had to, build an SMTP server and connect to an aggregator, and it was all nasty and expensive. So he said, why isn't that an API and make it easy? So with that, Twilio was born. Now, fast forward a few years to probably, I would say, 2014. The company came out with its first SDK for WebRTC in the Programmable voice protocol stack. I joined the company in 2016, and by the time I joined, the video stack was in place, still in beta, no longer in beta. Those are two of the things I'm going to talk about tonight, and plus a third, which is built on top of those two foundations, that's a programmable contact center. I like to think of Twilio as being like a box of Lego bricks, which are used to assemble communications applications. We provide the APIs, the bricks, so to speak, and our customers and builders like yourselves come and build the applications using those. Let's talk about what Twilio does with WebRTC on the voice side. And I should first add that we have a voice stack and a video stack. Right now, they're separate things. With programmable voice in Twilio, there are three types of endpoints that you can send a call to. There's a good old phone number through the public switch telephone network. There are SIP endpoints, which may either be a PBX or something like that that is attached to Twilio over a SIP trunk, or it might be a device like this. I've brought a prop with me, a SIP phone registered with Twilio. Those came along first, and then we added WebRTC, which is the third leg of the stool. So with WebRTC, what we've built is we have built a JavaScript SDK on top of the browser. We support Chrome, obviously, Firefox, Safari, and Edge. So this JavaScript library sits on top of the native browser APIs. It provides signaling, so you can connect to the service. We also have SDKs for Android and iOS. Now, those do not rely on a browser. They are self-contained SDKs that you build in an application, right? So there's no mobile browser dependency there. In terms of the media codecs that are supported, the lowest common denominator in the telephone network everywhere is something called G711. Sometimes you've heard it referred to as PCMU or PCMA. PCMU is the version used in North America and Japan. PCMA is used pretty much everywhere else in the world. That's the basic lowest common denominator, and up to this point, that's all we supported in the browser as well. We've just, believe it or not, just started support for Opus, which is a modern codec with very good properties for bandwidth utilization and voice quality. And as well as that, it's quite good at handling bad network conditions. So here we have the three legs of the stool, so to speak. How do you actually process a call? So when a call comes into Twilio from, say, the telephone network, it trips a webhook. And the webhook says, okay, customer, what do you want me to do with this call? And the customer's application needs to send back a chunk of XML. That's our dialect, we call it TWIML. And typically, what that would do is I'm going to connect that call somewhere else. So you might dial another phone number somewhere on the public switch telephone network. You might connect to a SIP endpoint, or you can connect to a WebRTC endpoint. Well, okay, how do these WebRTC endpoints work? If you're familiar with SIP phones like this, when they connect to a network, they're going to register, and when they do that, normally they do so with a username and a password. You don't want any old, device to connect to your network and commit toll fraud. WebRTC is no different in that respect. You need to validate who's connecting into your network. So the technique that we use is we tell customers, you've got to create a token, a JavaScript, a JSON web token that you're going to hand to your endpoint. You're going to sign it using your account credentials, and you're going to ask the application running in the browser or in the mobile device to present that token to Twilio. That token is going to tell us which account the device is associated with. It's going to tell us what it's permitted to do, and it's going to tell us, how long it's got left before it has to renew the token. So that's the security mechanism. So when you've built your web app that's going to connect somewhere else, you're going to probably have a button in your browser that makes a call somewhere. When you make that connection, you create a connection object. Surprise, surprise. Under the hood, we use something called SIP over WebSockets, right, which is a common way of doing signaling for WebRTC. WebRTC itself doesn't specify any signaling protocol, but a lot of people use SIP because it's there and it's easy, and people have built adapters for it for the use in the browser. So you connect to the network, and then you go off somewhere else. Similarly, you can kick off a call from within the Twilio network. Your application hits our API, our REST API, and says, I want to make an outbound call to the telephone network, a SIP endpoint, or a WebRTC endpoint. And when that happens, as soon as the connection is made, we're going to say, okay, now what do you want to do? That here's some more TWIML to tell you what to do. It might be to connect to an IVR. It might be to place the call somewhere else. So those are the basic mechanisms we use in the voice stack. Now, for video, it's similar in many respects. The browser support is the same. There is a SDK for Android and for iOS. It's based on a C++, chunk of C++, with adapters for the environments, whether that's Objective-C or Java. We do have some customers who are using the raw C++ libraries in Linux-based devices as well, and I'll describe one of those later. So same browsers, same methodology, same way of getting a token for permission to connect to the network. The programming model is a little different. It's based on the idea of a room that the participants connect to. So you can see there's a ready application there in conferencing. There are two versions of this. There's the peer-to-peer version that Chad mentioned earlier, where there's a signaling stack in Twilio which is basically coordinating the participants and ensuring they can find each other. There's negotiating the media, that's the audio, the video, which could be a camera or it could be the desktop, and the data connection, which we refer to as a data track. The other version of this is basically with a selective forwarding unit sitting in the middle on a server in Twilio somewhere. And the job of the selective forwarding unit is to take all the media streams in from the clients and selectively send them out to whatever client is looking for it. There are also media processing duties that the SFU does. It does recording, so we record all the tracks, all the audio, the video, and the data off to disk. It connects into the voice stack, so you can have someone dialing in from the good old telephone network, joining the video conference without the video. If you are recording a conference call between people, sometimes you might want the output of that to review later. There's something called the, I forget the exact name, it's a compositions API, which allows you to tell the system, I'd like the recording to show the dominant speaker in a main window and other speakers in little postage stamps at the bottom. So that's another thing we can do. There's speaker detection in there. All right, so that's one of the fundamental components of our software stack. What can you use that for to build? Very common application is the contact center. And we've made a huge bet on that particular line of business. The guy who runs the contact center business in Twilio reckons he has about 4/5 of the company working for him. Right? That's how important it is to us. He says the other 1/5 belong to the programmable wireless group, and we don't care about them. But that's not true. We should care about them because they play a role here as well. So, Chad, I'm going to just flip. I'm just going to demonstrate this thing. There we go. So this is a Flex Media desktop running in my account. It shows an agent, that is me, represented by the green rose of Yorkshire. And here comes the call. Thank you, Chad. Let's, I didn't plug in this, but you can hear it. Right. Okay, Chad, speak to me.
Hi.
Okay, great.
Yeah, you can hear me.
Fantastic.
I'm trying to stand far away, so
all right.
too much horrible echo.
There you are. All right. So that's a very short and very unusual interaction between a customer and a contact center agent. This is not rocket science. It's not like augmented reality. I was talking to someone in the audience earlier about what he was doing, and I go, yeah, this is contact center. This is simple stuff, right? It may be simple stuff. Well, it isn't really simple stuff. There are a lot of moving parts. But it's a very important market to address. I've read figures that say there's $34 billion in the contact center market. And WebRTC is one of the things that is helping us get into that market. I'll describe some of the reasons why WebRTC is so important to us going in a moment. All right. So that was a brief and mercifully short demonstration. Let's go back to the presentation. All right. So in a contact center environment, we're using WebRTC primarily for the audio stream for the agent. And people are probably dialing in from regular phones but there's nothing to stop you embed something similar in a company's web page and say, click to talk to an agent or a sales representative, and it can go WebRTC in and WebRTC out. The other thing that some of our customers have done, they're using video. Video has some particularly useful properties in that you can see the other person. Well, big deal, like you say. Why is that important? Well, in the banking industry, if someone wants to open an account with you and you don't have a local office, there are some rules about knowing your customer. Being able to see the customer and have them upload a document that confirms their identity is an important thing to do. Screen sharing. The obvious application here is with help desks. So, within an organization, I'm having trouble resetting my password. Where do I do that? Off you go. You may have noticed that I haven't mentioned data channels or data tracks here. To be honest, not many of our customers building contact centers are using the data channel for that. There's one exception that I know of. I'll talk about that. For things like synchronization between participants in a conversation, we actually use WebSockets. And, for example, web chat is based on WebSockets using an underlying persistent in-memory database. We don't use the data channel for that. So that's just an aside there. So what can we do with video apart from look at someone applying to open a bank account? There are some obvious applications. Telemedicine is potentially a huge one, perhaps even bigger than the contact center. The figure I saw for that said 40 billion total addressable market worldwide. I don't know where these figures come from, but the marketing team seem to pull them out of their hats. E-learning is even bigger than that, almost by an order of magnitude. It's not just classrooms, but it's professional credentialing, exam proctoring remotely. I've seen that one. Now, IoT. What does WebRTC have with IoT? Well, the smart doorbells you get these days that show the person walking up to the door? What do you think the protocol stack is in that? You've guessed it, right? So one of the things we do is we can, one of our little sidelines is the wireless business. You can get Twilio SIM cards, right? You can put them in your wireless devices and you can stream video from them. There are some not so obvious applications of video. One of the well-known and major manufacturers of elevator cars is outfitting its elevator cars with video emergency call buttons. So in the car, there's this display panel. Behind that, there's a Linux single board computer, embedded computer. It's running our C++ video stack. There's a button which causes a webhook to be set off to create a video room. It uses our task router, call routing system to summon, someone on a security desk. There's a problem in elevator number 6. If they don't answer, it goes off to a centralized contact center at the elevator company that does the maintenance. This is the use case where we do use the data channel. And it's used for text messaging between the security desk or the contact center and the person calling for help. And one of the reasons text messaging may be important there is that it's designed for the hard of hearing or the deaf, right? So there are buttons on the panel that they can use to say yes or no in response from a query, are you okay, and so on and so forth. An ambulance dispatch system. This particular one is done by Zoll EMS. They have a suite of products for summoning ambulances and dispatching them. They've added to that the ability for someone in an ambulance crew to actually do push-to-talk. Now, this is actually using a video room, but without the video. One of the reasons why it's an appropriate choice rather than using our programmable voice stack is because it's using the Opus codec, which is good for where the network conditions are bad or where there are bandwidth constraints. All right, so that's a good choice there. and the synchronization of the push is done using our sync product, surprise. There is also video sharing, so someone in the ambulance can call ahead to the medical facility and talk to a doctor about what's going on with the patient that they're transporting. So 2 uses of video for that use case. Augmented reality, it's an emerging use case. One of our customers is Magic Leap. You may have heard of them. And this next one I really like, the video portals between offices. This was basically a project that was put together by Brent Marshall, one of the developers at Shopify. Shopify are using our contact center product, but they were playing around with the APIs, and this guy said, hey, we could do some fun stuff with this. So he got a couple of basically video panels that yay big. He placed them in their offices in Ottawa and Toronto and places like that, and set up a camera in them with there's a little there's a microcontroller, an Adafruit trinket. He was telling me. He said, you press this thing and it takes a photo of you, and then it posts the QR code on the video board at the bottom. You can see on the screen there, and then you can get your phone, capture the QR code, and then you can download the photo. I thought that was really neat, right? So he just hacked this thing together as almost a throwaway app. He said, yeah, we after the company meeting we dismantled it, but we're thinking we may resurrect it again for just because it's cool. We'll put it in the reception area. All right, so why should you use WebRTC? One of the key reasons is you can tailor the user experience to the application. You're not stuck with what Polycom or whoever else gives you, right? I love Polycom, by the way. They're great phones. It gives you video, right? Surprise, surprise, there is no video equivalent to the public switch telephone network. The little islands of video, there's Facebook Messenger, there's WhatsApp, there's Skype, right? But there is no universal video network. So, as a developer, since you don't have something to tap into necessarily, you can build it yourself, right? You can do things that you couldn't do before. If you're in the business of providing a communication platform as a service, it means you're not dependent on what's going on your customer's premises. If you're sending a call out to their contact center and they've got, a VIA communications manager or Cisco call manager, and they've got those phones on their desk, you don't necessarily know what's going on those phones. You don't know if they're on hook, off hook. You don't know their availability, unless you tap into those PBXs and relay their status information back. And that, frankly, means you have to have a component on the customer's premises, and that is a royal pain. All right, so you can do it all in the browser. You start the thing up, you get the experience you want, it's there. If you're a customer of a service like ours, you don't have to buy the infrastructure. That's one of the key arguments for going to the cloud in general, but it's doubly true with communications. Some of the people who are moving over to us are doing so because they were faced with upgrades on their infrastructure. 2 minutes, yes. Right, so that's a forcing function. And by the way, all the upgrades happen whilst we're in production, so you don't have to worry about them. And you control the end-to-end experience. So if you're going through the telephone network, you think it's good, it's reliable, that's not necessarily the case. One of my experiences with one of my customers is they provide language translation services, and they're making calls out to interpreters, right? They were complaining that a lot of those calls are failing, and it turns out that you can't control the telephone network, calls drop, you get one-way audio, and with WebRTC, you can control the experience. So what are the issues? Bad audio quality or no audio, right? So the 95% of the problems is normally with the customer's network. Occasionally overloaded CPUs causing things to lag. Browser bugs. Thank you WebRTC Hacks for publishing a recent piece on the the acoustic echo canceller 3 debacle in a certain version of Chrome. Hit one of our big customers, New Voice Media. I've also come across instances where Chrome is sending 33 packets a second rather than 50 for PCMU, which is not right. Normally cured by restarting the browser. If you have one-way or no audio, it's normally firewall settings, this thing, the web proxy, or you may have something wrong with your camera or microphone. So if you're going to install WebRTC, you're probably going to run this thing, the network test. It will tell you about, can you get through the firewall? Is there anything getting in the way? It'll ask you to record some speech, and it'll play it back to you so you know everything's working. And as you see, it goes through a whole range of things. Does video work? Does audio work? Does all the rest work? If you do have problems, one of the great things that the web browser gives you is call statistics, and we'll hear more about that tonight. You can pull those out of the browser, and we send them back to a server every 5 seconds, and when the call is over, we attach those statistics to the call log entry, so an administrator can go back and look and see whether there were problems with the call. Other things you can do, of course, with those stats is you can display feedback to the user. So you're having bad network quality. Maybe you should take note of that, so they know there's something going on, not blaming you. Parting thoughts. There are huge market opportunities that go with WebRTC. It's critically, it's crucial for things like building cloud contact centers, right? And a whole class of applications going into the cloud from the premises. People like us are major beneficiaries of this, and this gives me another opportunity to say thank you to Google. You've given me much beneficial employment. Thank you.